Good afternoon, everyone, and welcome to the Manhattanville sessions of the first Columbia AI Summit. I'm Garud Iyengar. I'm the director of the Data Science Institute and a professor at Columbia Engineering. The Data Science Institute is the operational home of Columbia AI and a hub for interdisciplinary research in AI and data science. At this institute, we don't just ask what AI and data science can do, but rather emphasize what they should do. Our stated mission, Data for Good, is about ensuring that AI and data science are developed and applied in ways that serve humanity. AI is advancing rapidly, shaping industries, institutions, indeed, everyday life itself. Today's discussion, the first one on AI and creativity, and the second one on AI's role in leadership and the future of work, reflect its broad impact. Columbia is uniquely positioned to bring together experts from across disciplines, from law to policy, journalism to engineering, from the sciences to the arts, to ask the right questions and ensure AI reflects human values and serves the public good. Indeed, few universities in the world have Columbia's breadth and depth of expertise. The Data Science Institute and Columbia AI are able to leverage these deep interdisciplinary strengths, differentiating us from similar efforts in other universities. At the Data Science Institute, we lead interdisciplinary work through research, through events like this summit, through partnerships that bridge academia, industry, and the public sector. Columbia AI is another hub for engagement. The website, ai.columbia.edu, let me repeat it, ai.columbia.edu, a very simple URL, is your entry point for AI research, news, events at Columbia. If you're looking to get involved, please start there. Everything AI-related is going to be reflected on that website. I also encourage you to connect with us on Data Science Day on April 2nd. That's Data Science Institute's flagship event, showcasing cutting-edge AI and data science research and its industrial impact. Many themes of today's summit will continue in those discussions. The conversations that are happening here today, here in Manhattanville and across Columbia's campuses, reflect the strength of Columbia AI. The ideas and partnerships that we hope emerge from these discussions will have the potential to shape how AI is adopted in the creative fields, how it influences leadership, and how we navigate AI's growing role in the workforce. These are just a few of the critical areas that we are examining in the summit today. I encourage you to engage, connect, think boldly about the role we, Columbians, can play in shaping AI's future. And for those of you who can't be in the room, there's the live stream, and most of these events will be, and the key takeaways from these will be posted on ai.columbia.edu and datascience.columbia.edu, so follow us there. Thank you for being part of this summit, and I look forward to the discussions ahead. And now, I would like to introduce Professor Naeem Mohamed, a professor in the Department of Visual Arts at the School of the Arts, who will be introducing this session. Thank you.
Thank you, Garud. Thank you, everyone, for being here. Good afternoon. Just a few introductory remarks before I hand over to my colleague, Laura Kurgan, to moderate and run the rest of the event. As some of my colleagues at the School of Arts have commented, the future impact of AI on creative culture is hazy. In the short term, we expect massive dislocations in the valued, compensated work of creatives in all spaces. The long term, that is one of the things our panelists want to think through with you. Our students entered this period via science fiction paths of cyborg imaginary and sentient decision-making, encapsulated in Philip K. Dick's novel, Do Androids Dream of Electric Sheep? 90 years ago, Walter Benjamin presented the work of art in the age of mechanical reproduction, his idea of an aura that was present in handmade painting and absent from early mechanical photography. This was 1935. While providing a caution, Benjamin also had great hopes for photography as an emancipatory toolkit that could see things with clarity. Last year, in the School of Arts campus lecture series, Machine Visions, we encountered hesitation among industry leaders to come and speak to our students, as the question of plundering visual artists' work for machine learning training sets had become a key concern in the media. Considering the challenging questions our students ask visiting speakers, I can presume some technology leaders do not have an answer about the why. During the pandemic, I started an exercise in my class where I would ask students what they remembered about the morning of 9/11. Then I would show magazine covers from 2001, followed by covers of September 2020. Eventually, I had to put aside this exercise because unless you had MA and PhD students in your class, the reply was frequently, "I was not born yet." An exercise in faded memory works differently when it's a received memory from others. And now we live in a world of constantly contested memories, and we're working within an AI toolset that can invent photorealistic tableaus out of synaptic calculations. Imagine the illustrator who, in 1953, was handed volume 1 of J.R.R. Tolkien's Lord of the Rings with an instruction to dream up what Mordor and Sauron look like. The ultimate act of invention out of whole cloth with no precedent. Because fantasy novels don't have to make serialized sequence sense, AI engines that have vacuumed up fantasy novel covers can quickly generate a new genre book cover. Look at the artist's class action lawsuit against Midjourney. Fantasy illustrators were among the first plaintiffs. Many artists now express a desire to slow image consumption down. We spend our time with existing images in the archive, using AI tools to give them new meanings, rather than giving in to the pressure to always make new images. We find our students to be a healthy mixture of curious and skeptical. They are not attached to any imperative to always be eternal sunshine. And now, in the spirit of many parallel universes at the same time, we turn to our 6 panelists who will each present concepts and case studies from their fields on the question of AI and the creative impulse. And I turn over to my colleague, Laura Kurgan, Director of Computational Design and Practice at the Graduate School of Architecture, Planning, and Preservation. Thank you.
Thanks so much, Naeem, for setting up the panel so well. I'm going to do something very small at the beginning and just tell you who's coming up to talk. So our first panelist is Dennis Tenen. He's an associate professor of English and comparative literature, and he also co-directs the Center for Comparative Media. He's a rare English professor whose code runs on millions of personal computers worldwide, and he's published 2 books, Plain Text, The Poetics of Computation, and Literary Theory for Robots.
Thank you, Laura. And then, how are we doing? Okay. Oh, looks like they're all number 1. That's great. So I'd like to use the time to talk about AI and creativity, and specifically what the English department and more broadly the humanities, how these fields are being transformed by artificial intelligence. Now, the first and perhaps most obvious place to start is to say that artificial intelligence has a history beyond the last decade, you'll be surprised to know. And so there are a number of courses and a number of interesting research projects coming out of our discipline that deal with the history of artificial intelligence. I'll just tell you, since time is short, I'll tell you a quick anecdote. So for example, Markov chains, which is a statistical algorithm that lies at the heart of some of the technology producing AI, the original paper written by Markov was an analysis of Pushkin's poetry. And so that lies squarely in the field of literary scholarship. And then as my research shows, some of the first generative AI, the kind that you can talk to and the kind that can generate stories, was built on the work of Roman Jakobson out of Harvard and Levi Strauss, who was an anthropologist, and other researchers who were interested in the structure of fairy tales and generally kind of plot and narrative and other themes that are key, that are central to our discipline of literary analysis. So there's much to do on the historical front. I teach a course called literature in the age of artificial intelligence. I've taught it for many years now. It's there's always a wait list, and it's a course where we take some of these historical machines and some of these sort of paper and ink bots, and also early, story generators that were designed for mainframe computers, and we recreate them in class to both think about the history and the future of possibilities of writing with AI. So that's the historical part. The second thing I want to cover is that it is clear that the way we write today is changing, and we need to prepare our students to write in the industry. Now, whether they're going into a legal profession or medical profession or the many creative industries or the publishing industry, the practices that are observed in the real world are changing rapidly, and also we are in this moment where it's not clear how those changes will exactly take shape. And so I feel a responsibility of studying those changes more systematically and responding more quickly to the needs of creative industries and the need to other industries where knowledge creation and writing are at the very center of what they do. To this end, I have partnered, or the department has partnered with the Writing Center. We have a very lively Writing Center that's part of the English department. They are tasked to teach our students, bringing their level of writing to kind of a Columbia standard, but it is also becoming clear to us that thinking about how writing with AI, how that should look like, and what it means to write with with AI in a way that answers to our values and to our standards of excellence. We have a pilot program that was sponsored by Amy's office, by our EVP, and so together with the Writing Center, there'll be a class it's part a theoretical class, part a philosophical class, but part also a practicum on what it means to write for AI, and that class will be offered as soon as next semester in the fall. Finally, I want to say that AI lowers the barrier of computation to computational analysis, and I think scholars in all fields will relate to this, whereas a decade ago, it would take you several years to get up to speed to doing computational work. Now, whether you're doing physics or computational chemistry or computational biology or computational social science or indeed computational literary analysis, that training period was quite intense and difficult. The barriers to entry have been lowered, and that means that more of our graduate students are able to participate in doing computational research in our field. To this end, we have partnered with SKKU, which is one of the oldest universities in Seoul, in Korea, Toronto, and Harvard, and we're launching a pilot summer school this summer, actually, in Seoul, where we'll be inviting our graduate students to skill up and to kind of an entry point of computation in literary analysis, in history, and in social sciences. Now, a little bit, my own work also falls somewhere between those three bullet points. My most recent book is Literary Theory for Robots, which is the historical part, as I've mentioned. And also these days, and probably my next projects, in the last year or so, we have, there's been renewed interest in the Narrative Intelligence Lab, which is a lab I co-direct with several colleagues, including colleagues from Harvard University. And we are interested in broadly the impact of artificial intelligence and other sort of mechanical or automated incursions, let's call them, into our discursive media sphere. And we look forward to many more interesting projects, hopefully research projects coming out of this lab. Thank you.
Next up is Catherine Griffiths, who has recently joined Columbia as an assistant professor at GSAP in computational design practices. She's a designer and researcher who works at the intersection of critical AI studies, social documentary, and algorithmic visualization. She makes visible the relationships among the ethics of machine learning, labor relations, algorithmic governance, and the future of work.
Hi, thank you for the opportunity to share some of my work with you. Okay, so my work, I would describe it as sitting at the intersection of an emerging field called critical AI studies and computational design, where I focus on the politics of machine learning in society and the development of custom software to visualize, probe, and raise questions about those issues. So today I'd like to share some excerpts of several projects with you and some of the concepts behind their development. So critical code studies informs my approach to thinking about AI and its entanglements. And I think of software as I think of source code as a neglected but omnipresent cultural text that we should think of it as being available for humanistic and creative interpretation. And so that means taking code out of the idea of it being purely technical and only available for computer readability and computer execution, and trying to bring it into legibility and meaning for broader audiences. So for me, that process extends into art and design. And through this approach, I try to understand the ways that algorithms, and today that frequently means machine learning algorithms, shape sociopolitical dynamics, especially as they're deployed in more socially sensitive domains. So visualizing algorithms is a kind of design tactic that's a core part of my practice, which for me is spatializing computational structure and process in real time. So what we see here is an interactive software piece developed in the Unity game engine, and it visualizes a simple machine learning algorithm, a generative decision tree that's used to make classifications that become decisions about who has access, in this case, to social housing, and who has access to disability benefits. So very much decision-making that is of social consequences. And in making this work, I was interested in opening up a predictive system and understanding, first of all, spatially, where decisions are made. So you can watch as individual data points, which are the colored circles, which are people, being passed by this internal network. So a question for me is, can this approach to software support a sort of re-engagement with decision-making in prediction systems where we're perhaps at risk of losing our connection to it? And I'm interested in these terms like the problem of interpretability and explainability solutions in machine learning, and a desire to reframe them as not just technical issues, but also entangled socio-political dilemmas. And therefore, there is much a question for the arts and humanities to grapple with and contribute to, as they are for computer scientists to reconcile and solve. So for me, it's about bringing code from the inside of an algorithm into legibility and using a visual language to make that accessible. And then slow computation, or maybe slow AI now, is another tactic that I work with. For me, this is purposefully slowing down computational process to meet the human scale of perception and understanding. The nature of computation is a process that happens beyond the human scale of perception. It's hyperfast, it's obfuscated for most, it's technical, it's abstract. So this quality of slowness especially in this new world of massive, interpretable, impenetrable models that we're living through. I'm thinking about how knowledge is said to now emerge through an AI system, and how can we find a way back to that relationship to knowledge generation. So these pieces were shown in an exhibition at the Centre Pompidou in Paris called Neurons, Simulated Intelligences. And as an exhibition piece, I'm interested in how we can render algorithms more sensorial, how to engage the human gaze in algorithmic process, in predictions, in the same way that one might spend time in front of a painting in a museum, engaging that particular type of time, a kind of contemplative time. And then reflexive software, for me, this entails recognizing an algorithm as constructing an argument. From it has a viewpoint, and it's trying to achieve not just an extrinsic task, but potentially an ideological operation. So then the visualization of algorithms and interface design, software development, these all become a medium for exploring this type of socio-technical investigation. So in contrast to traditional software development that produces tools to perform an extrinsic task, reflexive software development is critically reflecting on its own code and functions and processes. It's what Yanni Loukissas might call interfaces that cause friction. And then another creative component of my practice is counter data sets, which means building alternative data sets to probe some of the issues that I'm interested in. So working with counter data is a design propositional practice for how we can think about counter arguments in software design. Also building on the work of Mimi Onuoha's project of missing data. So it includes what I term the unmodeled, and how we can think about particular human values or perspectives that could be encoded into algorithms, but in fact are missing. And then finally, this piece also comes from a counter data set approach. And it's part of a much bigger project in which I filmed my mother in her own home and then reenacted her domestic tasks to create an alternative motion data set as an algorithmic rendition of this labor. And I'm interested in the way that 3D digital asset libraries and data sets as a whole often embody this notion of agnosticism, the idea that they can be taken from one place and used anywhere else. And I wanted to build a more politicized, creative library of motions and activities, in this case, pointing to a gendered labor. So it's also a data set that comes from part performance or reenactment of someone's life. And the final slide is just trying to think about the near future of the home as a space that produces these data sets that could be used to train domestic robots and other learning algorithms that are set to enter intimate spaces and care settings. So thinking about the privacy of the home as a domain targeted by kind of the looming vectorization of the body and intimate space. I'll leave it there. Thank you.
Great. Okay. Next up is David Benjamin, who is founding principal of The Living. It's a small architecture practice, and an associate professor at GSAP as well.
Oops, sorry about that. Thank you, Laura and Naeem. I'm excited to be part of this important conversation. Let's see, does that work? Yes. So first, I'd like to acknowledge the incredible team that I work with. For the past 15 years, we've been aiming to combine some of the benefits of human creativity with some of the benefits of computational analysis. And in addition, we've been trying to test out some different AI approaches in real-world physical projects. So this is Twin Mirror for the Seoul Biennial of Architecture in 2017. And here, and here we combined two machine learning models based on two different sets of data. So visitors approached and saw themselves reflected back through these two versions of reality. Neither version of reality was neutral or objective. Both of them were biased. And by seeing them together, we could start to develop a kind of critical instinct for how the technology works. In addition to the gallery component, we also showed this project on the streets of the city in Seoul. And so with this as background, I'd like to quickly describe 4 different approaches that we've been exploring that combine AI and creativity. Number 1, generative design for lightweight structures. A few years ago, Airbus, the big airplane manufacturer, developed a lightweight concept plane for the year 2050, but they also wanted to start testing this concept with a real-world demonstrator. And the demonstrator they selected was a partition for today's A320 planes. So the partition, shown here in red, looks simple, but it's actually very difficult to design a partition that is both strong and lightweight. So we used a computational method called generative design to explore a wide design space in search of options that were both high-performing and unexpected. In other words, we created a custom software workflow to generate, evaluate, and evolve literally tens of thousands of design options, including some that were very unusual and many that were beyond typical rules of thumb. And then we used techniques like principal component analysis to explore trade-offs and home in on some of the best possibilities. We also used 3D printing and a new alloy to test the partition out in the physical world. This is the largest metal 3D printed airplane part, which consists of 60,000 microlattice bars. And here's the 24G static test of the full-scale component, which we successfully passed, and the partition is now being certified to fly in today's commercial airplanes. The new partition is 45% lighter than the traditional component, and if it's installed in all of the A320 planes flying today, it will reduce carbon emissions by about 1 million tons per year. 2, generative design for complex buildings. So here we used computation in the design of an airplane factory. Instead of 2 goals for the airplane part, we had 10 different goals for the factory, including operational, financial, environmental, and social goals. And for example, here's the way we calculated the production efficiency of a factory layout, measuring the flow of materials and people between logistic spaces, assembly spaces, and paint spaces. And here's a self-organizing map that compresses some of the 10-dimensional data that we had into a 2-dimensional graph. And here it's important for me to note that the computer and the math offer us a good set of designs, but they don't produce a single design. The final design requires human stakeholders to exercise judgment and make collaborative decisions. 3, machine learning for circular materials. So this is a new building that we designed for Princeton University for things like experiments with robotics and sensors and everywhere that computers meet the physical world and become so-called embodied computation. And to reduce carbon in this building, as one of our kind of sustainability ideas, we decided to make the facade out of repurposed scaffolding boards from New York City construction. And these boards would otherwise end up in a landfill, so this was a kind of idea of using a sustainable material. We basically developed the hypothesis that this kind of weathered wood with these micro contours you see here might offer some thermal performance benefits in terms of trapping small pockets of air, and also some hydro performance benefits through shedding water. So we knew that a material might offer these kind of performance benefits, but we also knew that zones of the facade had different performance requirements, as this solar analysis shows. And we knew that we had thousands of boards with different properties, to arrange on the facade. So the question became, which board with which properties should we put in each position? The areas of wood with the narrowest grain tended to provide the best performance, and the areas around the knots in wood tended to have the narrow grain we wanted, so we set out to identify and treat the knots in each of our boards. First, we photographed all the boards, and then we used a little bit of human training, asking people to look at photos and click not with the KN or not with an N. And after some initial training, the algorithm actually got pretty good at seeing where the knots were, even in photos that had never been seen or classified by a human. Here's the algorithm homing in on the knots, and it was fascinating that the human had simply stated whether each photo had a knot, but the human didn't circle it or describe it, and then the computer was able to look at a new photo and not only figure out whether the photo had a knot, but also find the location and the size of the knot. So after using machine learning to identify the knots, we created a custom robotic sandblasting machine to treat the knots and produce the kind of micro contours we wanted. And overall, this allowed us to explore kind of a new approach to materials. Practically, it allowed us to reuse materials and reduce the carbon footprint of the building. And conceptually, it allowed us to celebrate variation rather than reducing it, and to overturn this kind of lowest common denominator approach to materials. The facade itself became an example of embodied computation, and in the end, the building suggests a new hybrid design approach that combines human intelligence and machine intelligence. So for the last one, large language models for site layout. So this is a software project called TileGPT and a building project called the Phoenix, which is a 300-unit affordable housing complex. And here we started with the prototype for so-called example-based design, where a designer provides a catalog of parts and enters some examples of how those parts should fit together. And then a software system that we created learns the desired patterns and creates new designs with the same properties as the example designs. And then we developed the prototype into a no-code software workflow where you can enter natural language requests, including requests for formal features or performance features, and then you receive layouts that correspond to your request. So the result is a design for a specific plot of land in Oakland, and also a tool that can be reused to make sustainable decisions on other projects in the future. So here's a vacant lot that will soon become this net zero affordable housing complex. Thank you.
So next up is Francisco Ramirez, who is pursuing a master's degree here in the visual arts with a concentration in photography. And transformation is a constant subject within his work, so I hope he's going to show some of that.
Thank you for the introduction. Hi, I'm Francisco Javier Ramirez, and I am an MFA, first-year MFA visual arts student in the photo concentration. Like Laura said, my practice explores transformation, but focuses on queerness and immigration through my personal experience and new ideas of the photographic image. In my recent work, I've been thinking about utopias, myths, and the American dream, focusing on my father's migration from Mexico and how it repeats with my own story. My father's family converted to Mormonism when he was a child, and he migrated to the US in 1990 when my mother was pregnant with me. These are passages for which I do not have any images. Therefore, I was interested in AI's capabilities to create an archive of those images that don't exist. For instance, here in this photo, there's a man who could resemble me and be my father. And yeah, it could be an image from him in his first years in the US, a family portrait that previously only existed in my mind. I think maybe I can use this one? Yeah. This one's a little short for me. Through my work, I am often questioning religion and what it represents in American life. I believe Mormonism was important in my father's story and his aspirations for white American suburbia. For this project, a narrowband right above the horizon, I wanted to collapse the real and the fiction. I used AI to generate new old archive and blended it with the real archive of found images that included the historicity that we carry combined with prompts based on my personal history. I was conscious of the cliches and stereotypes that AI could easily reproduce, and I was looking for contradictions, finding artifice in reality and reality in artifice, collapsing the idealized images from media and AI and the real reality of history. It is reflected in these scrolls that we'll see in a minute, where images from various sources were flattened from multiple layers of meaning into a single one through a series of processes. First, I printed a new archive of man-made and machine-made images in different sizes but similar materials. Then I manipulate images by painting and Xeroxing them before arranging them into a composition, like I was doing there, on the table to be scanned with a handheld device. The lower resolution handheld scanner desaturates images and causes a loss of detail, introducing imperfection where there was only certainty. Creating a blend of realities that took away the sheen of the AI images and made it more believable. When I generated a Mormon temple, it was always an idealized white building with this awe-inspiring mountainous landscapes and cascades flowing. And if I asked it to generate a Mormon missionary, it was an attractive white young man every time. Technology is simplifying things into a single possibility that cannot understand the contradiction of the human experience. So when generative AI thinks of a Mexican man in Utah, it still represents the cliches, the hat, the pickup truck. It can more easily render a believable American suburban street because its points of references are those that have already been shown many times. When I was selecting the images from the 3 archives I compiled, I was not fully interested in the reality in which we exist, but rather in reflecting my own thoughts of what I understand it to be and what I thought it to be when I was a child. Using the error of the mechanical device, like the scanner, I can control the artificiality and resemble the flow in which we exist. And as the title of this series suggests, a narrowband right above the horizon is a mirage. I consider these works to be in process, but I like how they start to create an atmosphere. I still think that for the audience, it needs a point of access. So in that sense, there are other projects that I've created where I do straight photography and incorporate certain elements of AI that are more legible. This series, David cruising at Prospect Park. And well, this is just a photo. Okay. The project is a sequence of photos where I am using an app called Sneefies to cruise in Prospect Park. This room may not know, but Sneefies is a well-known map-based cruising app. So I am there using the app. And cruising is an act of seeking out sexual encounters historically in semi-public spaces by queer people. As I'm cruising, I feel a presence, and as I turn around, I see David Wojnarowicz. David was a gay artist, writer, and political activist from New York who died of AIDS in the early 1990s. And when I was making this series, I was thinking of queer life, all the people who died in the AIDS crisis, and how even now, as queer people, we carry that stigma. So when I am bringing David back from the dead through AI, I am asking myself, what would it mean for David to still be alive, to be older, and to still be doing the things that he would do, like cruising? That's the queer utopia that Jose Esteban Munoz talked about, where past and future exist in the present and we have hope, but also examining how queer culture has been commodified by technology to the point where we now have apps for cruising. And while I'm cruising, I find David, and what do? I take a photo. Thank you.
So next is Mark Hansen, who joined the Columbia Journalism School in 2012 from a long career in statistics, and he runs the Brown Institute for Media Innovation.
Thank you, Laura. Thank you, Naim. No pictures. I'm very happy to be here today. And my contribution will focus on creativity in journalism. My background, as Laura mentioned, is in statistics, and I teach computational journalism in the J School here. In my classes, we explore the way new technologies like AI might impact the practice of journalism, and the flip, how the needs of journalism, its unique methods of investigation, and its underlying values and ethics, how these might shape the priorities for new research in AI. What just happened there? Well, this will be an adventure. Journalists both report on as well as with AI. Are called to serve the public good. We are called to serve the public good, but do so in a way that prizes verification. These are the starting points for creativity in the profession. Across the country, AI is finding its way into sourcing and information gathering, into structuring and analyzing data, and eventually shaping how we present our work through new ways of reaching audiences. So I'll briefly talk about the state of play in journalism. The relationship between AI companies and journalistic outlets is complicated, but generative AI has found its way into newsrooms small and large. This is the Washington Post's Ask the Post AI application that distills answers to news questions from published reports. Also from the Post, we have, and elsewhere, AI is creating automated summaries of reader comments and their articles. This is why I said this would be a little bit of an adventure. At the City, a local publication serving New York City, they've developed an AI tip bot that makes it easier for you to submit tips about landlord violations or issues with local government by dynamically asking you for as many details as possible about the event. Under the banner of AI, newsrooms use models to sort through vast quantities of information, including text, images, and videos, creating structure and spotting patterns. This has fueled incredible new reporting, like this piece from the Times that poured through satellite imagery of Gaza to spot where 2,000-pound bombs had been dropped. You might be surprised at how sophisticated these kinds of projects had become. In an early move, one newsroom even trained an LLM dubbed Bloomberg GPT, although recent advances in the big commercial models have outpaced the advantage that this model once had. And of course, any discussion of creativity and AI should address the importance of journalism as content used in training models. With local newsrooms across the country blocking AI bots with entries in their robots.txt files and others making deals. I'm not sure how these got so out of order, but anyway, others making deals with AI companies. Local news is staking out unique territory. It's creativity dealing in people, places, and situations that might not appear in other available content. To give an example of the twin roles of reporting on as well as with AI, let's consider the Washington Post again. After Michael Brown was shot in 2014, the Post began collecting data about the extent of police shootings across the United States, culling data from news reports, law enforcement websites, social media, and creating structured databases from those unstructured sources. This kind of task was manual in 2015 and is now automatable in 2025, with a balance between public good and verification found at the center. Full disclosure, the Post is shutting down this site, but looking for modernization in a new home. So if anyone here is looking for a worthy project to keep alive, this would be it. Once regularized, the facts of each event are exported into a table, which can be read into an LLM, in this case ChatGPT, and analyzed. What's the incident count per year? Here we have it as a table or as a line plot. Importantly, by generating code via an LLM in the context of data analysis, we have a secondary artifact that a data desk or a colleague might be able to check before publication. Appealing to AI or to various analysis agents, we largely shift the prized form of creativity in data journalism away from the ability to turn questions into code, and instead value the ability to ask good questions in the first place. And this is what the J-School curriculum is all about, curiosity and asking questions. But even in this simple context, we see the reporting on versus reporting with roles. In my computational journalism class last year, for example, we looked at the Household Pulse Survey from the Census Bureau. It was the Bureau's first product to ask about sexual orientation and gender identity. And somewhat remarkably, it's still up on the website. This was part of a larger theme in my class last year about queer tech, establishing a beat about how technology impacts the lives of LGBTQ people and how perhaps their lives have inspired the development of new technologies. It was an introduction to data and computation that was heavy with GPT assistance. In an early move, we looked at the ages of respondents to the Household Pulse Survey to compare it against the US population. GPT gave us this lovely histogram, fine. I then found from the Census Bureau that there were these other amazing, lovely plots called pyramid plots that compared population across age and sexes. Light blue for males, dark blue for females. We asked GPT to make us one from our data, and it gave us, this is asking GPT, and it gave us this. What's the difference here? Male and female, pink and blue. My point in bringing this up is my point in bringing up this simple example is that the biases in training data slip into even what we might think of as very dry technical work. Journalism's duty to report on and with AI is perhaps something we should take on broadly as we use these models and platforms, especially when it comes to our creative practices. Thank you.
So we have our last speaker, and the 5th out of 17 schools across Columbia are represented on our panel. So Sheena Iyengar is the inaugural S.T. Lee Professor of Business in the Management Division at the Columbia Business School and a world expert on choice and decision-making.
Good afternoon, everybody. Now, I'm blind, so you need to do a little better than that. Good afternoon, everybody. Perfect, thank you. Need to make sure you're all awake. So, my name is Sheena Iyengar, and I've been at the Columbia Business School for the past 25 years. And as the moderator just announced, I've been studying choice my entire career. And the big question that I study is, how do we get the most from choice? And I've written a couple of books on it. And about 10 years ago, I started to ask the question that more than just being able to find the best choice in a whole array of lots and lots of choices, how do we create meaningful choices? After all, we live in a world where we're often confronted by meaningless, trivial, illusory choices. How do we create those meaningful choices? And that led me to a path to create a methodology that's based on neurocognitive economics, sciences. I began to teach that methodology in the last 10 years, and more recently, I've even enhanced it now through the use of generative AI. So let's start with the question that underpins this methodology. Where do big ideas come from? Who gets them, and how do we get them? And so in the interest of the topic of our panel, I figured I would start with art. So I'm going to ask you a question, and I want you to just call out your answers. Who do you think made this piece of art? Just call out. Picasso. Ah, she's a smart one. Okay. Who do you think? Indeed, it is Picasso, 1901. Who made this piece of art? Absolutely. Notice the transformation in the style. And certainly, historically, whenever we think of great artists, great thinkers of any kind, we convince ourselves that these big ideas come to us almost like magic. You know, maybe you were given some divine revelations when you climbed the mountain. Maybe an apple just happened to fall upon your head when you were sitting, and then you got an insight that showed you some great insight about the world. Well, we now know that it wasn't magic, and in fact, we know through a lot of recent advances in science about how our mind actually creates ideas, and in large part, ML and AI have taken advantage of that knowledge. So, how did Picasso get this transformation? What was a technology that came into being in the 19th century that completely disrupted art? Guesses? Yes? Did you say yes? Yes, indeed. It was photography, right? Because back then we would make portraits. And suddenly you had this thing that could take pictures and capture people in real life more precisely, more quickly, more cheaply. From today, painting is dead, cried one critic. Yet another critic cried, it's not long before art will be entirely supplanted by the camera. But the only thing I have to do is change the word camera with generative AI, and I think we're perfectly comfortable in modern times. So, Picasso, like all the other realists, is searching for a technique. You know, because we all know that art didn't die, they just found new ways to see. And so, in 1906, Gertrude Stein invites him to her salon in Paris, and there he beholds this famous painting by Matisse, The Joy of Life. Take a look at this painting. Now, Matisse was very much influenced by his mentor, Cezanne. Take a look at this, 5 bathers. And Picasso asks to meet Matisse, and they meet in a cafe. And while heading to the cafe, Matisse happens to pick up an African sculpture that had just come in from one of the French colonies, so he brings that along to his meeting. It is recorded by Matisse's secretary that throughout their meeting, Picasso held that African sculpture and he kept fingering its lines, its ridges, its angles, and that very night he started to paint La Demoiselle d'Avignon. Take a look at this. So, a contemporary of Picasso, T.S. Eliot once quipped, immature poets imitate mature poets steal. So was Picasso a mere thief, or was he like any great innovator, artist, scientist, entrepreneur, someone who takes ideas drawn from distant and diverse sources and combines them in a new and meaningful way? Schumpeter, in the same era, the great economist, said that all innovation is nothing more and nothing less than a new combination of old ideas. And certainly the work of Eric Kandel, the Nobel Prize-winning neuroscientist, showed us how in our brains we simply take lots of different memories, bits of information, and keep combining and recombining them until we might stumble upon a big idea. So, a number of years ago, I began to think maybe we could actually take this knowledge and create something prescriptive, and give people a type of toolkit that would enable them to create their best ideas, their best solutions to whatever complex problem that they were attending to, either in their personal or in their professional lives. And I created a course around it. And the course is called Think Bigger, and essentially drew on what we had already learned from neuroscience about how the brain works, from cognitive science about all the things that get in our way, and it essentially applied the theory of Schumpeter. So these are the 6 steps. Choose a problem, break it down, compare wants, search in and out of the box, choice map, and the third eye. Essentially what it is you define the problem, you break it down, and you go out into the world and you search. How has anyone solved this problem in different places? And you take those pieces that you get from diverse places and you combine them until you create a unique solution. Now, I used to teach this the hard way, the long way, and would have students spend weeks searching. But just this past July, we rolled out a new generative AI app that literally does those 6 steps. And we found that in a 5-day boot camp, you could actually get students to now create entrepreneurial ideas which they can actually get funded for. These are just some of the ideas that just came out in the last few months, like a way to help people detect if this food they're about to eat in a restaurant might affect their allergies, how you might diagnose if your kid has a learning disability, to name just a few. And I'm going to end by showing you the QR code in case any of you want to test it out. So with that, I want to encourage everybody to believe that, yes, we can all think bigger. Thank you very much. Thank you. Please.
5 minutes? Oh, is this on? Can you hear me? Yeah, okay. So thank you all. This was a really amazing panel. And as I predicted, I should have written an algorithm for it, but there would have been no purpose for it. Not one person over here told us that AI was going to replace us as humans in making art. It was furthest away from that. And in fact, what everybody did was tell us how creative they are in using AI in alternate ways than it might have been, for which it might have been, invented or created or stumbled upon, et cetera. So Dennis is talking about, not using AI to write, but to figure out how to use it in a more creative way. Let's call it creative, right? In a way that is actually a good thing to teach our students. And Catherine was, obviously taking apart AI, but really interpreting it and explaining it to us in a creative way that allowed us to enter into the algorithm in a creative way. And David brings qualitative as well as quantitative inputs, right, into a design problem, really massively expanding the dimensions through which we create a design space for architecture. Francisco, beautiful in terms of how to recover memory through AI, which is not something I had ever thought about. I think that is such a creative use of generative imagery. And Mark, reporting on AI, I think has some similarity with the way Catherine is interpreting and the accountability that we all have to bring to AI. And Sheena, I would associate you with a kind of design thinking process, but in a more but specifically for art, and that the ways in which design thinking actually comes out of a computational design space and makes everything a little bit more methodical than artists would. So I don't know if we're allowed to actually have a discussion, but I would like to sort of ask, everyone. We all know. I think that's a good summary, I think, of everybody's talk. And I really am, hugely optimistic that no one even thought through the idea that, AI is ever going to completely take over human creation of art or creativity. Thank you. Okay. And I've also been instructed to tell everyone to stay in their seats so that the transition to the next panel goes more easily. Thanks so much.